So the reason I'm so interested in consoles is that designing with console users in mind helps make better sites. So at the moment, we really only consider 3 forms of input: mouse, keyboard, and most recently touch. But we barely even seem to design for keyboard these days. But consoles, they force you to consider a whole range of inputs that are just starting to creep in, things like gesture and voice. It makes your design more accessible because you're thinking about D-pads and keyboard input. You think about how a site might work not just on a very small screen, but simultaneously a very big screen. Web TV is getting more popular too, and TV consoles are a great place to start learning about this context. Basically, console browsers are the ultimate torture test. As soon as I started talking about console browsers, I got comments from a few people saying that just because they don't personally use them, they don't think that anyone else does, and therefore they're safe to ignore. Or that they tried one once and the experience was so bad that they don't understand how anyone could put up with using one. So not only is this not a reason to ignore other devices out there, but we're completely the wrong demographic. 51% of children have a portable console like a PlayStation Portable or Nintendo DS. 80% have a TV console in their home, like a Wii, PlayStation, or Xbox. And Ofcom did some research and found that 1 in 5 children visit websites on a game console. They also found that low-income households are more likely to have a console than a computer. In other words, this may be the only way some people can get online. Pew Internet, which is based in the US, found that kids are almost as likely to go online using a console as a phone. And it makes sense because many kids that age either don't have a phone or they don't have a contract with a data plan. And a lot of parents don't like the idea of giving kids internet access on their mobile phone. But it's not just kids who use consoles. 1 in 8 adults access the internet on a console. And consider our attitude to phones several years ago. We'd say, oh, nobody would want to do this task on their phone, so let's give them a simplified experience. People expect to do the same things on a console as they've been doing for years on desktops and phones. We've had browsers and consoles for around 16 years. These are some of the portable ones that have browsers. The first was a Game.com in 1997, and the rest are various flavours of PlayStation Portables and Nintendo DSs. The DS models, they have 2 screens, but only the bottom one is a touchscreen, and they're resistive rather than capacitive. A resistive screen is one like in the back of an airplane seat. You have to push quite hard, and the capacitive ones are like the ones on your smartphone. The PS Vita, it has an optional 3G model, which is worth thinking about. These are the TV consoles with browsers. In the late 90s, the Sega Dreamcast came out with an inbuilt modem, and you could get the browser on a disc, and the same with the PS2. The Nintendo Wii has an Opera browser, and the Xbox only recently got a browser, which is i9, and they said it was something that a lot of people had been asking for. And then there's a Wii U, which is the latest TV console, and it has a controller with a touchscreen. And coming up soon, we've got the Ouya, which is a console running Android. You might remember this. It was a very successful project on Kickstarter. And this is a proposed portable Android console with a touchscreen on the front from NVIDIA, and it's set to be released soon. And the Razer Edge, which is a tablet that can be docked into a keyboard or this gaming cradle. And we're seeing lots of devices like this, not just consoles, but tablets that can have touch or keyboard input. So consider that when you're thinking about designing the tablet experience. And last week, the PS4 was announced. The new controller has a capacitive touchpad on the front and a button on the controller that lets you share what you're playing with the web. And the web is becoming more ingrained into consoles and a whole range of other devices, so we need to take them much more seriously. Most console browsers use a WebKit version of NetFront. Nintendo used to use Opera browsers, but they moved across after the DSi. I run the HTML5 and CSS3 tests, which give me an indication of the level of support that browsers have. So the PSP 1000 couldn't run either test. It's quite an old device, and the browser has very buggy CSS support, and a lot of sites break. The DSi has an Opera browser. It couldn't run the CSS3 test, but it scored 89 out of 500 in the HTML5 test. The 3DS XL has slightly better support, but it's still low given that this device was only released at the end of last year. And the PS Vita recently got an update to its browser, so now it scores very highly compared to other console browsers. The Wii scores 89 out of 500 in the HTML5 test, which is pretty low, but remember this device came out in 2006. The Xbox 360's browser came out a few months ago. It uses i9. The Wii U came out in November, and it has the best stats of all console browsers, and that's because the console is brand new and has higher specs compared to the others. So one common problem that consoles have is that they don't have Flash, and they don't have support for the HTML5 video tag. The ones that do have Flash installed, the version that's installed is often so out of date that Flash plugins won't work. But there's really high demand for video content on the TV, and companies like YouTube end up having to make separate apps for each device. And I think this is what's driving device makers to support standards. So you're probably wondering why the stats are generally so low. It's because consoles have very limited memory allocated to the browser. So as an example, this is the original Nintendo DS. And to get the browser to work on it, you have to buy a browser cartridge. This is an Opera browser. And you also have to get this memory expansion pack, which you push into the bottom. And that's because the onboard memory, it's only got 4 megabytes of onboard memory, and that just isn't enough to run a browser. They were built to play games, not to browse websites. This is improving as consoles get better and they can pack more memory in. But just remember that they're not updated as often as phones and computers. So in case you're not a gamer, here's a quick introduction to a generic game controller. So this one is the PlayStation's, but they're all very similar. Analog sticks are basically like mini joysticks. Some controllers let you push the stick in as an extra button. It's quite a nice noise. The D-pad is like the arrow keys on your keyboard. And the triggers, there's usually 4 of these on the back of a TV console. The portable ones only have 2. The Wii only has 1. I call the ones at the top bumpers on the portable consoles, but I don't think that's a technical name. So as you'd expect, the console experience is very different. Typing with a D-pad takes a long time. So this is a PSP 1000, and it's particularly difficult to type with. If you remember what it was like texting before phones had full keyboards, it's kind of like that, but it's even harder because this isn't a touchscreen. All you've got is a D-pad. This is a keyboard on the Xbox, which is better, but it's still very slow using the analog stick. So they've spaced the letters far apart to reduce mistakes, which is great for things like touch and gesture. But with an analog stick, it takes a long time to traverse from one letter to the next. And the Wii is even harder. It's like a laser pointer. You have to point at the letter that you want with the Wiimote, and that's very fiddly. One nice feature it has is that you can switch the layout to single column mode by pressing 2. And that basically forces the page to lose layout styles, and that can make the site easier to use. Some consoles take advantage of all the buttons on the controller for the browser, and this really helps. So this is a PS3's controller, and it takes a while to learn all the buttons, but it makes browsing a lot faster. And this is a PS Vita, which is by the same manufacturer, but the buttons are barely used at all, and it relies heavily on the touchscreen, and I think this is a bit of a waste. The Wii U has lots of browser controls, and I counted 4 different ways to zoom. Zooming is really important on a TV console, so most websites haven't been designed for TVs, and the text is very small when you're sitting far away from the screen. So that's why they've got so many ways to zoom. There are other ways of browsing, such as using the Xbox Connect, which recognises voice input. You can search the web by shouting, Xbox, Bing, Adventure Time. It usually gets it wrong, but it's still quite cool. The Xbox also has something called Smart Glass that lets you connect an Android or iOS phone and use it as a trackpad or keyboard. And I like this because it makes typing a whole lot easier, and it means you don't have to buy an extra device. It's using one that you've already got. So I just wanted to show you a few quirks of some of these consoles. So the DS range, it has these 2 screens. On the extra large version, the top screen is wider than the bottom screen. Only the bottom screen is touch enabled, and it's not capacitive, it's resistive. You get this stylus, and this is how pages look on the device. So remember that only the bottom screen is touch. They actually load starting on the bottom screen, but I've started to scroll up in this screenshot. So you can always click on something that's at the top of a page. When you zoom in on text on the 3DS XL, the text automatically wraps to fill the screen, so you don't have to scroll horizontally to read long lines of text. And I think this is a really nice feature. You might be getting excited about the fact that it's a 3D device and you're using a 3D device to browse the internet, but the 3D capabilities aren't enabled in the browser. You can view 3D images, but not within the page in the browser. You have to download the image first to see it in 3D. And the image format is .mpo, which is basically 2 JPEGs on top of each other. And the fallback is just a single JPEG. The Wii U came out in November, and its browser is miles ahead of all the others, and it uses a lot of HTML5 features. So the Wii U's gamepad, this is it. Has this really nice big screen and a stylus, and you can use your fingers, but you have to press quite hard, and it's a very different experience to something like a tablet. It scores 100% in the ACID 3 test, it supports SVG, and it supports HTML5 video. It basically mirrors everything that you're looking at in the gamepad with the TV, but a key thing to bear in mind is that TV browsing is often a group activity. So Nintendo have thought about this, and they've added features to encourage that. So when you're watching a video, you click on this button to continue browsing while the video continues to stream on the TV. So now it's not mirrored, and you can queue up videos to watch. And it basically turns the Wii U into a presentation device. You can also hide what's on the gamepad from the TV by pressing a button that draws the curtains. Then when you're ready, press a button to open them. And it's a really nice feature if you use something like Instapaper. You can scroll by tilting the gamepad and pressing the back triggers. That's kind of a feature that you get in Instapaper. I quite like that one. If you're playing a game and you switch to the browser, you basically suspend the game so you can continue playing it after you've had your session in the browser. It asks you if you want to start a search with the game's name. And that's great for if you're stuck and you're looking for walkthroughs and you don't want to type the whole name of the game. And you can even use the gamepad as a TV remote. And I think the interface is a lot better than any other TV remote I've seen. So the Xbox's browser, it has 2 user agent strings. The second one is when it's pretending to be a mobile phone. And to get it to do that, you check this box in the browser settings, and if sites have a mobile version, they display like this. I think they've added this option because mobile interfaces are generally easier to use than traditional desktop interfaces. And what this tells me is that we need to make our sites just as easy to use on any device as we would for a mobile phone. So to sum up, here are my 5 tips for designing with consoles in mind. Device detection doesn't consider future devices, it pigeonholes, and that's the same with user agent string sniffing. So this PS Vita thinks it's a Kindle Fire. Having something tell you it's a game console, is that really going to help? Because as you've seen, consoles work in all sorts of different ways. Some are touch, some gesture, and let's say you're going to detect that someone has a Kinect and give them a different experience based on that. You're basically making an assumption that they'd rather use that than, say, an analog stick. There is a way around this. In Matt's words, making something better for some people might make it better for way more people than that. So here's an example of that. The new A List Apart site, it looks really great on lots of different devices and lots of browsers. Articles are single column and the text is nice and big, so it's readable from a distance. Don't try and cram lots of stuff in like other sites. And they do nice things like making clickable areas really big. It feels like a website that was built for the web. So plan from the very start how what you're designing is going to work on different devices. Not just layout, but whether things like the colour scheme is high contrast enough for low resolution screens, or whether any fallback fonts that you've chosen will be readable. During the design stage, prototype, test and iterate little and often, and keep doing it and test on real devices. The file size of our website is getting bigger and bigger, and the consequence of all this extra stuff is that, as well as being much slower to download, sometimes sites don't work at all on consoles. This is because the amount of memory consoles can allocate to the browser is very limited. And it's not just consoles that have this problem. I've seen this error message on web TVs too. Performance is a really big part of the user experience, and I'd argue it's the most important part, because if someone can't load your website, they're never going to get a chance to judge what it's actually like to use. So have a think about that next time you're thinking of using a custom web font or something like a carousel, because that decision could cost you users. Since every decision that the designer makes has a performance cost, set a budget. Performance is not a layer that the developers can just add on. We can only do so much. It needs to be the designer's responsibility right from the start of a project. Navigating a site using a console's D-pad is an example of why focus styles are so important. So the Wii U adds its own default blue outline, but an event part highlights the text that's already focused, making it even clearer. And it's the same with gov.uk. So many devices are coming out right now that are touch-enabled. So rather than try and detect touch and serve up a different style sheet, make your overall design work for touch-enabled devices. So this is a BBC homepage on the Wii U. It's really easy to navigate using lots of different inputs, so things like D-pad, gesture, touch. It's nice and readable from a distance. It's got big clickable areas, really simple interface, really good contrast as well, because TVs are really bad at contrast, so bear that in mind when you're designing. Microsoft get it. They know how to design for multiple inputs because they built the Xbox. They don't need a completely different UI for each device because it works with any form of input, and that's where I think we should be focusing. I think we need to make our sites not adapt to the different environments, but be built for all of those possible contexts. And that's going to be challenging, but I think that's the nature of the web. Paul's web aesthetic article on A List Apart has had me thinking a lot lately about how our limitations influence design. So the challenge of designing for the web is that it's not static, and we can't always detect what context the user is in, or what screen they have, or whether they're inches or feet away from the screen, or even what input they're using. So embrace that. If you're interested in learning more about this, have a look at the resources on my console site. I've already put up a link to these slides, so you can have a look at them straight away. Thank you.
Fantastic. Oh, by the way, thank you to everyone who brought second-hand books along that we can distribute to schools. That's another one of Anna's initiatives, the whole Scrunch Up thing, which is pretty fantastic as well. She's amazing. So next, Andy Hume here used to work at Clearleft, and it was a pleasure working with him, but then he ran away to London to work at The Guardian, which is a pretty awesome opportunity, and really interested to hear what he's got to say about what's been going on there. So, ladies and gentlemen, Andy Hume.
Hello, everyone. My name's Andy. I am indeed from The Guardian. Today, I'm going to talk a little bit around the theme of performance. And I'm going to do that in the context of this, which is The Guardian's new mobile website. At the moment, it's delivered only to mobile and certain tablet devices. Over time, we're scaling it up to the point where it can replace the desktop site on www.guardian.co.uk. So it's kind of a big deal for us. But first things first, I'm kind of assuming that this is a given. If you're interested in the performance of your websites and you haven't done this yet, then this is the first thing that you do. None of the stuff that I'm going to talk about in the next 20 minutes is the first thing that you do. This is the first thing that you do. gzip, compression of content, far future cache control headers. A lot of things in web performance are nuanced and quite tricky to get right. This is really easy, and it will have the single biggest impact on how users experience the speed of your site. gzip and caching. Web performance is obviously a massive topic. There's a whole bunch of things that, in terms of performance, you might want to optimize. In the 20 minutes that I've got here, I'm going to focus in on just one of those, and actually just a quite specific part of that one as well. And that's page load time. How quickly and reliably can we actually get our content, which in our case is the news, in front of people? How do we optimize this infamous metric, page load time? I'm going to start by defining 3 stages of a page load, 3 stages of priority. So the first is the content, the reason that people come to your site in the first place, to read the news. It's the thing we want to prioritize over everything else that might be on that page. Secondly is the progressive enhancement of that content. So perhaps some JavaScript that adds swipe interactions to a picture gallery or implements a carousel or a tab interface. And finally is what I've called the leftovers. This is stuff that the user doesn't care about. It's things like our analytics tools, third-party tracking, and in our case, advertising. So this is a very kind of high-level anatomy of a page load: content, enhancement, leftovers. So what does that actually look like when it comes to loading a page in a browser? Well, this is a waterfall chart from Google's PageSpeed Insights tool. If you're familiar with that, you might recognize this as the Critical Path Explorer. If you're not familiar with waterfall charts, you will be in a minute. This is basically showing every object that the browser loaded as part of showing that page. It starts at the top left and lists objects going down as time stretches along the bottom. And you can sort of quite clearly see these 3 distinct stages of the page load. At the top left, the blue bar is the HTML, the green bar is CSS, and that's the content. That's it. Those are the only 2 things required for the browser to start showing the news. If everything else after that loads slowly or fails, we still have a very usable, albeit non-JavaScript enhanced, core experience. In the middle, we load some JavaScript that add things like better touch support. We load Guardian web fonts, which I'll come on to, and other bits of conditionally loaded content, things like live football scores, most popular articles, things like that. And finally, at the bottom right, we have those leftovers, the bits that the user shouldn't need to care about. There's a call to omniture, which is user analytics. There's a call out to the ad server and some advertising images and GIFs and things. And the way that this works is actually really straightforward. We simply queue up the enhancement stage behind the browser's DOM content loaded event, which is indicated by the blue line going down there. And the leftover stage is triggered by the browser's load event, highlighted in orange. So this all seems quite straightforward and sensible, right? It's a nice, elegant way of prioritizing the news, embracing progressive enhancement, and putting the user's desire to read the news in front of everything else. But there are actually a whole series of trade-offs going on here. And I'm going to spend the rest of the time going through what some of those trade-offs are and try and explain or question how we've come to some of those decisions and how we might be able to improve or change them in the future. So, trade-off. This is how we load the one main JavaScript file on m.guardian.co.uk. And most of the developers in the room will have seen code like this many times. This is a pattern for loading JavaScript into the browser asynchronously. In other words, it means while the browser is downloading JavaScript, it can still go ahead, parse the document, and show content. The thing that we want to prioritize, the news, isn't blocked. But we're basically only doing this pattern because of old browsers. Modern browsers don't need this pattern anymore. Chrome doesn't need this, Firefox doesn't need this, IE9 and 10 don't need this. Modern browsers just need that, a good old-fashioned script element. As long as you include the new-ish HTML5 async attribute, the browser won't block parsing content while it loads this script, which is the only reason for doing the dynamic script load in the first place. But this has an added advantage in that the browser can see it in the HTML, it can parse it, and it can start downloading it much earlier. We can see that really clearly in these 2 mini waterfall charts. On top, with the script element dynamically added, the HTML, CSS, and JavaScript are all downloaded one after another in serial. With the script element below, in modern browsers, the JavaScript is downloaded in parallel to the CSS. It won't necessarily be executed until after the CSS. Doesn't know exactly when it's going to execute, and that's fine, it doesn't matter. But the time it spends on the network is up front alongside in parallel with the CSS. So the JavaScript executes quicker, and you can see that happening earlier. So if we changed m.guardian.co.uk to use a proper old school script element, instead of adding it dynamically, the waterfall might look more like this, which improves overall load times. So why don't we do that? Because if we did do that, then every browser would download the whole JavaScript application, even if they're not going to run it, even if they don't cut the mustard. I don't know if I need to license that term from the BBC. Is it acceptable for browsers to download code they're never going to execute? Honestly, I'm not sure, to be honest. Our default reaction was that, no, it's bloody well, they shouldn't download code that they're never going to run. But if they did, we could actually get faster page load times for more modern browsers. So we've traded off some performance in newer browsers to better support older ones, which is kind of annoying. And the reason for this is because the cutting the mustard code is in JavaScript on the client side. It runs somewhere about there in the overall page load, which is too late to optimize the load appropriately for different devices. And all we're doing when we're cutting the mustard is putting a browser into one of two buckets. It's deemed to be either a modern, capable browser or not capable. So what if we could move that mustard cut to the server side? So that we decide in the template on the server that capable browsers get a normal script element with an async attribute, and non-capable browsers get nothing. They don't get any JavaScript at all, which is what we want. That moves the mustard cut to somewhere off the chart over there. It means we get the improved load profile for modern browsers. So with a small piece of, I say small, with a focused piece of user agent detection on the server side, we can improve the load experience and the load times for all users without trading off one group of browsers against another. What's trade-off number 2? Well, God forbid it's more server-side responsive techniques. As we saw in the waterfall earlier, the biggest blocker to the page rendering is CSS. The browser doesn't want to show anything until it's got the HTML and all the CSS. And this includes CSS that might never be required on a particular device. An iPhone will still download the second style sheet here, even though the device will never show the page more than 320 pixels wide. So again, if we could make that decision about whether the browser gets that second style sheet on the server side, if we can reliably detect the device, we can give it the best chance of loading fast once it gets to the browser. So this approach of adapting content on the server side, sometimes a little bit sniffed at, it's not really a recognised best practice. And it's not necessarily simple either. You need a device database like Device Atlas or Wordful. You need to keep that up to date. You need to sensibly set vary headers. It's potentially all quite fiddly. But I think I provided 2 examples here of where it is of genuine value to the user if you can take this approach. Luke Wroblewski dubbed this sort of hybrid client-side, server-side responsiveness as REST, responsive design and server-side components. And it's not about serving different templates for different types of device, but it's about optimizing or tweaking small parts of the outputs that you give to a browser up front, so that it has a bit of a head start once it gets there. I should point out we're not actually doing any of this server-side detection on the Guardian site yet, but we absolutely want it as an option in our toolkit for implementing the best cross-browser experiences we can. Trade-off, web fonts. So Rich covered all this stuff really nicely earlier. Web fonts have clearly provided an enormous step forward for design on the web, without question. Perhaps the biggest single thing in the last 5 years in terms of pure design. But web fonts can have some pretty serious performance implications if you're not careful, because you either block showing content until you have the fonts downloaded, which means slowing down showing the news, or you render in a fallback font and swap in the web font once it's loaded, as Rich went through this morning. That affects the user's perception of load time a little bit, because the page jumps around, the text appears, and then it disappears, and then it reappears in the new font. And they're the only 2 options you've got, really, if you want web fonts. Take your pick. They're both a trade-off. So how have we handled this? This is not necessarily pretty either. The first decision we made is to approach custom fonts very much as an enhancement. For a start, if you don't cut the mustard, you don't get web fonts. If you don't support WAF, you don't get web fonts. And thirdly, if you can't write to local storage, or if we can't write to local storage for whatever reason, you don't get web fonts. You can probably see where we're going here. So in a script element in the head of our page, which is the first performance trade-off because this blocks content rendering, we do the following. We test for cutting the mustard and WAF support, and then we check to see if we've previously cached fonts in local storage. If the fonts are in local storage, then we retrieve them, write them into a style element in the head of the page. Then when the content is rendered, the fonts are available and we don't get any flash. If the fonts weren't cached in local storage, then we don't want to block showing the content while we wait for fonts to download over the network. So we kind of stop the font loading process until the content's rendered. Then we do a test to see if we can write to local storage. If we can't write to local storage, either because it's full or the user's disabled it or some other unknown reason, we definitely don't want to download the fonts. If we can write to local storage, then we download one JSON file which contains 4 @font family rules, the fonts themselves as base64 encoded data URIs. So it's one gzipped far future cached file. It's around about 100K, which I think is pretty good for 4 fonts. It's one of the reasons we chose, well, not the main reason, but a reason to choose WAF. It seems to compress better. Once it's downloaded, we cache that in local storage and then write the font face rules into the style element, and the fallback font changes to the custom web font. So that should only happen once for every user. Once they've got the fonts, they should never see that flash again. So why do we store them in local storage, you may ask, and not just let the browser's HTTP cache look after them? Well, it's because we don't trust the browser's HTTP cache, which is kind of a sad state of affairs. Research by Yahoo and others over the years show that it generally doesn't do as good a job at caching your assets as you would hope. Mobile devices in particular, in fact, don't have large caches, and in particular don't do a good job of persisting those over time. Earlier versions of mobile Safari on iOS, some of them had bugs where the cache didn't work at all. Others had an 100K total cache limit. Others would limit the size of one asset in the cache to 25K and things like that. It's got a lot better since then. But this is definitely a trade-off, caching fonts in local storage. It's not what we want to be doing long term. It's what we've been doing at the moment. It was kind of experimental when we wrote this code, but it seems to be working. It's been in production for 4 months, so I guess it's working to some degree. I hope a longer-term solution will present itself as possibly as part of some of the generally improving offline features in web browsers. What's emerging from Google as the sort of next generation of app cache specification is really exciting. It gives the client a lot more granular control over how and when assets are cached. So, images. I guess no talk on performance these days would be complete without something on responsive images. I know people are going to talk about this in a bit more detail this afternoon, so I'm going to use it more as a springboard for some other rant that I have. Media queries are the biggest distraction in responsive design. I'm going to struggle to qualify this now, but we'll see. I might do it better in the pub later. But in my view, if we're doing responsive design right, if the specs and browsers evolve in the correct way, according to me, in 5 years' time, we won't be using media queries, or even 2 years' time, we won't be using media queries to implement responsive layouts. There's increasingly a move to build websites with small, modular, reusable patterns. There have been talks today on, mentioning pattern libraries and system-based thinking. This idea of separating layout CSS from component CSS is being popularized by systems like object-oriented CSS and SMAX from Jonathan Snook. Increasingly, we want these kind of components of our design to stand alone. We want them to be flexible enough to work in any context they're placed in, on any page, in any layout, in any column width. These standalone components should really not be making reference to the viewport size. I hope the future of responsive design from a layout perspective will be more influenced by technologies like custom elements and the shadow DOM, and this set of technologies that are wrapped up in a spec called web components. This is the area in which I'd personally be keen to see sort of time and effort expended by browser makers and standards organisations, giving us a way of better expressing these kind of responsive rules at a reusable component level, not at a browser size level. Which I suspect is why I don't get hugely excited about new specs that are built with media queries in mind. So this is the proposed, currently working draft, possibly, picture element, which implements responsive images by letting me decide which image to load based on, you guessed it, the size of the viewport. I'm not sure if we'd find a use for this in the Guardian mobile site, for example, which is kind of a shame. Maybe we would, but it would be a pretty distinct and small set of use cases. It's nowhere near a responsive silver bullet. Or responsive silver bullet. That'd be cool. I like this. The BBC do this on many of their on their front page and some of their section fronts. We should totally do it as well, and that's my fault we haven't yet. You might have noticed when Tom was showing the core version, the sort of core content of the BBC homepage, the news homepage, there weren't any images alongside each of those article links, and that's because they're not in the HTML. They're loaded in as part of the enhanced version for HTML5 browsers. And the BBC seem to load these about 2 seconds after the rest of the page. But the point is, you can choose when to load those images, and you can choose whether you load high-resolution ones or low-resolution ones. And it's not... Yeah, this is an example of that. So at the moment, we load in all those images for all browsers. And there's quite a lot. I mean, images are at least 80% of the page weight of the Guardian mobile site's homepage. You wouldn't use this on images that are a core part of the content. You want those to be in the HTML, you want them to be loaded quickly, ideally by a pre-parser. And they're semantically important to the story. You know, if it's an illustration or graph, you don't take this approach. But when you want a little bit more control, I mean, we could choose to not load any images on the homepage if they weren't in the viewport. Now, there's other trade-offs there in terms of opening up connections on mobile devices and battery life and things, but it's an option. So that's some sort of specific areas of performance in relation to challenges on the Guardian site, and you might notice or think that there's not much about them that's particularly specific to responsive design, and I think that's true. Performance is clearly an important part of responsive design, and people recognise that, but it's an important part of all design and development. I'm not necessarily sure there's any general performance optimization methods that are necessarily more suited to responsive design. In fact, the more I think about it and work on these types of projects, the more responsive techniques, certainly from a technical point of view, just seem like a collection of best practices for web development in general. I think Tom alluded to this earlier as well. It's like, well, we always wanted to do this. That's different to the design challenges, which Sarah was talking about, but from a technical point of view, I mean, responsive design has certainly focused a light on some of the bad practices we've got into over the years, be that designing for large fixed-width screens or not considering mobile performance and generally not accepting and embracing the reality of the web platform, I guess. And I think, for me, that's the most exciting part about responsive design. It's not only is it a hugely pragmatic in the way it recommends approaching cross-platform design, but it also compels us to defend some of the kind of inherent strengths of the web that sometimes have got left behind in the past. Its accessibility, and to coin Tim Berners-Lee, its universality. And that's more or less, I think, what I wanted to say. So thank you.
Brilliant. Thanks very much, Andy. That was great. All right, then finally in this block, we have Mr. Bruce Lawson, who has come straight from Barcelona, where he was at the Mobile World Congress thing, which is this huge gathering of people in suits spouting buzzwords. And I'm really hoping that this will be the complete opposite experience for him, that this will be a nice antidote, and it will be very welcoming to him. Ladies and gentlemen, from Opera Software, Bruce Lawson.
Hiya, is this on?
Yeah.
Cool. Yeah, I work for Opera. 2 weeks ago we announced that we are moving to WebKit. I'm staying deliberately down here tonight so anybody can berate me or ask questions about that in the bar. There's no point in doing it now because that's not about responsive stuff. We also announced that we've got 300 million users across the world, by the way. I work in the web standards part of Opera, the web standards team, and my job is to help to write and help to promulgate the standards that you guys need in order that your sites work on any browser, on any device, anywhere. And this is basically a look at what's coming in the near future to help our jobs better. This is not like the W3C woke up and went, ooh, everything's responsive now, we need to get some standards out for that. The web has always been responsive. It's always been about working anywhere. It's just some of us have chosen to limit that. So this isn't anyway a Damascene conversion. Luckily, everybody here is really clever, so I can miss out some of the first slides. Remapping physical and virtual pixels. Does anybody not know what the viewport meta tag does? Brilliant. Okay, blah, blah, blah. Hey. Work this morning. Okay. What was somebody saying about browser-based? Thing is with the viewport meta tag, it's not to everybody's taste. Two problems with it. First of all, it's in HTML to control presentation, which is a philosophical problem. The second problem is a practical objection. Any device that supports a viewport meta tag will apply it, and that doesn't necessarily give us precise enough control. It doesn't give you as designers control that you may wish to have. You don't have to exercise that control, but it's nice for you to have it. So we demand better than the viewport meta, said a lot of drunk middle-aged men at a Christmas party. And we are getting it. CSS device adaptation. Now, you'll notice this logo. I was talking to Aral Balkan last night, and he pointed out that one of the things that helps the uptake of open standards and open source is attention to detail and beauty. So I've burned the midnight oil by making a logo to encourage uptake of the standard. If anybody from the W3C is watching, feel free to take it. This is viewport in CSS. And the image is saying, for those of you unused to such subtlety, make it work everywhere or you're a walrus, basically. So what happens here is we have viewport in CSS. This was invented by us in Opera. We were reverse engineering what Apple had done to document it and to specify it, and realised that we could express everything there as CSS. So this exists now in Opera Presto, it exists now in IE10, and WebKit support is happening as we speak. I asked the Firefox guys, and they haven't given me an answer, but they don't hate it, so I imagine that we can see it at some point. It gives us more as well, because in CSS viewport or device adaptation, you can have a minimum and a maximum width. And what that allows you to do is have more granular control. So here, I've said width 550 pixels and auto, and that says to the browser the minimum width the page can be is 550. So if your physical width is less than 550, map this 550 to your real width and make my design fill the whole page. However, if you're more than 550 pixels wide, don't remap, put the 550 in the middle of your real viewport. Got it? Looks like this. This is a site made by our friend Patrick Lauker for his wife. This is it on Opera Mobile on a smartphone. This is Opera Mobile on a tablet. And it just means that when you look at the tablet, it isn't all blown up and looking a bit Fisher-Price. It gives you control. You may not wish to exercise that control, but it's a design decision for you to take. This is already used in Windows 10 tablet snap mode, and you can see because the viewport is in CSS, it can be nested inside a media query. I kind of agree with Andy that media queries are not necessarily the way we'll be doing it in a decade, but they're here now and they're useful now. And the medium term, I think we're going to continue to use them. Okay, W3C Flexbox. Again, this is a logo I made. You'll know that if you really want to get sophisticated layouts that are independent of source order, you can feel a bit like that. And what you really want to do is just get your vision into the computer like that. Now, Flexbox feels a bit odd like that, but once you've mastered it, you're going to feel like Mae West is sitting on a lambretta and playing ukulele to you, which is something we all want to feel. Everybody familiar with Flexbox? Hands up if you don't really know how it works. Okay. It's a brand new box model. It does shitloads, but I'll just go and explain the most important stuff. Firstly, it has been through 3 different iterations of the spec. When you find articles on the web, they all express the concepts of Flexbox, because those haven't changed, but the syntax has. If you see any of those syntaxes, these articles are talking about an old version of the spec. So don't expect the code to work everywhere, although the concepts will work. So, first great thing about Flexbox, we get easy vertical centering. You say in your CSS that the parent is display flex. Then margin auto doesn't just center left and right, you will get it centered vertically. Just works. Very nice. You can line up boxes and make them know about each other and share the space either on a vertical axis in a column or a row, because not every language in the world is horizontal and it's a world wide web. So what I'm doing here is I'm saying that the flex flow is horizontal. It's a row, and then it looks like this. So imagine I want to center those in my horizontal row. You might think I do this, align item center, but no. Because aligning items does it on the cross axis. If I'm flexing horizontally, aligning happens on the vertical axis and vice versa. The cunning stuff is the flex property. What I'm doing is I'm saying each of these articles will flex according to this ratio. So this will look like that. If I change it, so one of them has flex 2, then it redistributes like that. And it doesn't matter how many children the parent has. You don't need to know. So maybe you've got some kind of toolbar in your web app where you have more buttons if somebody's logged in or according to different permission levels. It will just work, and it does just work. Justifying content, you have quite a few different ones to choose from. This is how it looks. They can bunch up at the start, the end, in the middle, space between, space around. Bob's your uncle, Mae West is on a lambretta and playing a ukulele. The great thing is you can reorder content. You can make the visual order entirely independent of the source order, which means that behind media queries, you can reorder blocks on your page at will. So here I'm making the article that has the idea of second appear first, and this is a screenshot taken from Opera, works the same in Chrome, and works the same in Firefox, and it just looks like that, which is brilliant. Now, I used to think that there was no way in non-Flexbox CSS to move things entirely out of content order. But there is, if you use a filthy hack shown to me by the guys who make Up My Street from My Society. This was shown to them by our host, Jeremy Keith. So it's entirely filthy, but I love it. So here we have a page. This is not using Flexbox. Can everybody read the main content, by the way, at the back? No? Can you now? Good. Yes, 400 people rickrolled. Okay, so this is the source order is the header, the nav, the main content, and the footer. and this is being used in a responsive redesign I'm doing for my own site. What I want, because my site's a blog, so people either come to the homepage to read my latest words of wisdom, or they follow a link to an individual article. Very few people actually navigate around a chronological blog. So what I want to do is put the navigation, the green block on the side, right underneath. And I want it underneath the footer because I want my important copyright stuff to be attached to the content. And you can do that, and this will work in IE8 and above. Let's have a go. Oh, bollocks. I tell you what, there's a special fun in being nervous and having MS when you're trying to press small buttons. Okay, so if I make that smaller, come on. And you see the footer stuff, the nav stuff, has just gone down to the bottom, which is pretty cool. The way that works, and it will work in IE8 as well, the way it works is this dirty, but beautiful hack. When the screen goes small, what we're doing is we're saying that the whole body should display as a table, and any table caption should be at the bottom. And the nav will stop floating and will display as the table caption. And this will allow you to take one element from anywhere on the page and have it at the top or the bottom. And that works without Flexbox, and it works across all browsers, including IE8, which is deeply marvellous. Okay, Media AM, when I came up with this one. Thanks, Aral. This is not CSS4, by the way. I used to call it CSS4 and got mocked by the standards boys. It's not. It is level 4. Things that are in discussion at the moment. There's a script media query. Does this browser, or rather does this particular tab in this browser, have script support? So instead of instantiating Modernizer and checking whether there's a class on the HTML element that says Node.js or JS, there's a media query for it. I believe this exists in WebKit now. Then you have things like a hover media query. Does this device support hover? And if it doesn't, then you can apply different styles or whatever. What kind of pointer do I have? Do I have a coarse pointer, i.e. a fat finger, or do I have a fine pointer, that is a mouse? If my pointer is coarse, a fat finger, I might want to make my buttons or my radio buttons bigger. You may not, but it gives you the option to do that. Am I paged? Am I interactive? Do I have touch enabled? Here's a really cool one. Do I have a remote control? If I do have a remote control, then I'm probably viewed at a distance. And this is important, as Anna said, a lot of people use TV, but a TV is an interesting and very different kind of browsing context. And if you ever have to do any TV development, there's one thing, just one thing, that you need to know, and it's this. This is a Samsung 50-inch television viewed from across my living room, and this is a Samsung Nexus S viewed at normal viewing distance. And the mobile phone is bigger than the TV. So don't think, because I have a 50-inch TV and it's really good high resolution, I can have 96 columns of text. You can if you sit that close to your TV, but you probably don't. So it's useful to know that you're a TV, because then you can take account of the fact that somebody's probably 10 feet away, or 3 meters if you were born before later than 1971. Okay, pointer events. I believe, I'm very proud of this one actually, particularly proud of this, because cyan and fuchsia rarely combine so well, I think. It is fuchsia friendly, if you will. David this morning was talking about one generic kind of events. The trouble is we know that keyboards work, and we have JavaScript for mouse, and there's touch, and there's gestures. But it makes JavaScripting complex, and it means that old sites need to be reworked, or you have to cross your fingers. So our good friends at Microsoft have written a spec called the pointer event spec. It's with the W3C. They've implemented it in IE10. It is a crackingly good spec. We at Opera like it. I know the guys at Chrome like it. The guys at Firefox don't hate it. No, I asked Arno van Kesteren, and he said we don't hate it, but we don't know if we're going to implement it immediately. But what it does, it is a hardware agnostic way. All it does is tell you whereabouts on a screen the pointer is at, and whether that be a mouse, whether that be a pen, whether that be touch, or whether that be a keyboard, doesn't matter to this specification. So it's really cool. It's deliberately modelled on the mouse events. So the idea is that you could just copy and paste and choose any on mouse down and just change it to on pointer down, and it would just work. TM. You also get new properties. For example, if you've got a pen on some kind of pressure-sensitive pad, you'll know how hard people are pushing, etc., what kind of tilt you're at. I think this is a really cool spec. I hope we'll see it soon. Opera, my friends at Opera, we like it. One thing we want to see added is that there doesn't seem to be anything in it that addresses things like games consoles where there are two different pointers, because two people are playing a game at the same time. That doesn't mean the spec is shit, it just means that we have to discuss it more, come up with the use cases and add to it. But I hope we'll see this soon. I've been doing it for time. Okay, adaptive images. This is the last part of the talk. Andy showed you some mechanism for adaptive images. But, I can't show you the demo because I just accidentally closed my browser and it was online. Okay, this is an SVG image. This is an SVG image. And the great thing with SVG, of course, is that it's vector-based, and therefore everything scales up and scales down without losing any resolution. So you'd think that using SVG where you can is a great way to get images that work everywhere. But I think it might be John Hicks, but a lot of people have talked about the art direction use case, whereby when things get very small, they might, various parts of the image, like this spiral that's in there, might start to interfere with the other stuff and just become unreadable. The great thing with SVG is these are not pixels, these are maps. So this spiral here is actually a great big long path with loads of coordinates, and it has an ID of spiral. And that outer circle has an ID of circle 1. And inside the SVG, inside the .svg, which is written in text, you can therefore turn things like that on and off with media queries. I've killed the demo because I closed the browser, but what I would do is I'd show you that when you shrank it down below 256 pixels, the spiral would disappear and I would fatten out the outer circle to get greater resolution. And I'll show you down the pub later. So it's a really good way of using media queries, not just in HTML, but to address the art direction use case for vector kind of images like logos. That obviously won't work in things like photographs, but it works for logos. Photos, there is a new-ish image format in the hood called WebP, invented by Google. It is actually a still version of their WebM video codec. And in their tests, they show that the WebP images are about a quarter smaller than equivalent JPEGs. This has nothing really to do with responsiveness in the buzzwordy sense, but if images are smaller, and images are 60% of most websites, 60% of the page weight is images. If you can reduce that, then your website will load faster and it will, by definition, feel more responsive. The trouble is, not everybody supports WebP. Google Chrome does, and Opera does. We did it because we have a product called Opera Turbo, which speeds up browsing on the desktop and on the mobile product. So we found that if people turn Opera Turbo mode on, we transcode JPEGs and PNGs and GIFs on the fly, re-encode them as WebP on our servers, send them into the web page, and it's still a quicker time to glass than actually dragging down that JPEG and rendering it, in most cases. Time to glass being a Ponzi way of saying how long it actually takes until it appears on the device. So it's generally faster. It uses more battery to decode. You get extra compression, but it requires greater CPU to decompress. So, as everything else, there's a trade-off. Trouble is, WebP isn't supported everywhere, but CSS Level 4 gives us the image value and replace content module. And this gives us a new way to give the source of a background image in CSS. So previously we had a URL, wavy.png. Now we get this other mechanism where you can give a list of images. What will happen here is if the browser doesn't support WebP, or if it tries to fetch the WebP and it gets a 404, it will then look at the next one on the list. So with this, older browsers that don't understand the level 4 syntax of image will get wavy.png and it's not worse for them. Newer browsers that do support WebP will get the smaller version, which you have to make, but you make it once and everybody's download is faster. And browsers that understand this module but don't support WebP will get the PNG, and everybody's a winner, except for you, because you have to encode some WebPs and stick them on your server. But you've got to do more work, and your users are happier, so they come back, and your boss gives you a favour, and they put a statue of you in the car park and worship it in the mornings. So it's good. So what about content images? We've got a way of having a different kind of image format for background images, and we have a mechanism of fallback in CSS, so if you don't support WebP, you can get another one. We don't have that in content images. So I noticed in about November 2011 that HTML5 gives you this for video. In other words, there is a mechanism in HTML5 video for browsers that don't support WebM to fall back to MP4. So it seems to me entirely sensible that we have something like this, so a browser that doesn't support WebP will get the PNG. This doesn't exist yet, but it seems to me a useful thing to want to do, because content images should be in the HTML. That way they download faster, because the browsers know how to optimize the download. That way they're available for doing stuff with, and they have alt text, so screen readers, etc., can get to them. This was kind of my idea, but I'm quite lazy and I like throwing out ideas and making other people do the work. So I'm very much thankful to Matt Marquis, aka Wilto, online, who works at the Filament Group, who's worked really, really hard to get a spec written with a friend of ours called Marcos Caceres. There's a spec now that is at the W3C being looked at that specifies an algorithm and all the various JavaScript events that will be associated. So I'm very much riding on his coattails here. And I am riding on his coattails regardless of what else it looks like might be happening.
We'll probably get the one that's more optimized for older browsers. So we'd probably have, we would send something that, we would send what we're sending now to everything unless we think it's Chrome IE9, IE10 on desktop.
So it's kind of like mobile first server side sniffing.
Yeah.
What you're not testing against a giant list of what you think is all the mobile devices out there. You're testing against a small list of what you're pretty sure.
Yeah, a white list of what you know, browsers that you know have these optimizations built into them. But at the moment we can't take advantage of them because we're trying to support a whole range of things. The other point worth making is you have to have some process and workflow around doing this in your team. It's no good to just say, here, we've done that, and then hand it over to another team or a client and expect it to work next year, because it probably won't. You need to have that built into your...
to the future, basically.
Yeah, and the future might be, we'll look at this again in 6 months and maybe we'll switch it off. Not everyone has that opportunity to say, we'll look at this again in 6 months. But if you do, I think that's...
So, Anna, I was kind of getting from you, you're not saying you should be designing for consoles or you should be designing for devices. It's more like you should be designing for everything and nothing.
Yeah, absolutely.
So it's like it's the unknown or the things you're not thinking about.
I worry about people designing for specific consoles because they work so differently, and you're basically just forking your code so much. And in a few years' time, there's going to be something new that comes out that we haven't really thought about. So I think it's a more general approach is better.
I agree. I think that applies to everything. Instead of focusing on mobile or focusing on tablets, focusing whatever, focus on the web, right? I mean, Bruce, you're giving examples there, and Opera has a long history of being left out because, you know, on the desktop, certainly not on mobile, but on the desktop being a minority that people didn't consider. And if people had just built according to the standards, it would have just worked in Opera. Mm-hmm. But they, in an attempt to give a tailored experience to the majority, they ended up hurting things for a significant minority.
There have been the occasional instances of people thinking that because me and my mates have an iPhone, everybody in the world has an iPhone, and there are people without them.
It's true. I've seen them. All right, could we get the lights up and we'll get some questions. We don't have too much time, but you've already asked a question.